We're solving problem 12 from the 2025 AIME2. Let A1, A2, all the way to A11 be an 11-sided, non-convex, simple polygon with the following properties. For I is greater than or equal to 2 and less than or equal to 10. The area of the triangle A sub I, A1, and A sub I plus 1 is always 1. For every integer I is greater than or equal to 2, less than or equal to 10. Cosine of this angle is equal to 12 over 13, and we know that the perimeter of this 11 gon is always 20. And this sum basically here simplifies to this, and we want to solve this right here. So what we can notice is that this is a form that you might actually be pretty familiar with, because this basically is literally just a Pythagorean theorem. You have the negative b, and then you have the square root, right? Except only it's simplified, and then you have the denominator. So what we want to solve for is probably going to end up looking like this right here, the Pythagorean theorem. So the first thing we want to do in this problem is set variables to certain lengths to see if we can make do with anything. And we can do trial and error on the first triangle. So if we set A1, A2, this length is x, A1, A3 is y, right? And then we have the area of this triangle is equal to 1. Now the area of a triangle can be solved in various different ways, but for the sake of this argument, we want to use it, the specific formula for the trigonometric area. So it's going to be 1/2 xy sine theta is equal to 1. So here, well, we have that theta is less than angle A1, A1, AI plus 1. And then, basically, from here, what we can do, since the cosine of this angle is cosine angle theta, we'll just say theta is this angle, right? Cosine theta is equal to 12 over 13. We know. So that means sine theta is equal to 5 over 13. Therefore, plugging this in here, we can isolate xy, which is going to be equal to 26 over 5. Now, this was just the first triangle, but we can repeat this process for triangle A sub I, A1, AI plus 1. And from this, we find out that our length A sub 1, A sub 2 is equal to A sub 1, A sub 4 is equal to, eventually, the length A sub 1, A sub 10, which is x. Similarly, A sub 1, A sub 3, A sub 1, A 5. This is eventually equal to the length A sub 1 and A sub 11, which is equal to y. Now in this case, to find this sum, we would use a Pythagorean theorem, and we have a third side, right? If there's 9 triangles and there's a third side of the 9th triangle, right? We use the Pythagorean theorem. So you basically just sum the squares. So you have x squared plus y squared minus 2xy cosine theta. From here, we're basically cruising, right? So you have x squared plus y squared minus 2xy is equal, 26 over 5 times cosine theta, which is going to be equal to 12 over 13, yeah. all of this basically simplifies. X plus y squared minus 20. And since we have 9 of these sides, right, we know the perimeter is 20, so you square root it, multiply by 9, and add, all right, so, there's 9 of these sides, right? For simplicity's sake, let's just set a to be equal to x plus y. Then we can use this perimeter, right, to get, so here we have 9 root a squared minus 20. You have to add another a to get the full perimeter is equal to 20. And then you basically just have a quadratic, right? You want to isolate a, so you can subtract, divide, square. You get 4a squared plus 2a minus 101 is 0. This is now a simple quadratic where we have a is equal to -1 plus or minus 9 root 5 over 4. So we have it in the exact form over here. So that's our answer. We have 1 plus 9 plus 5 plus 4, which is going to be equal to 19, our answer for this problem, and we are finished.